So the purpose of this video is to continue talking about piecewise functions, but more specifically, graphing them by hand. So what we're going to do is we're going to graph each function and then talk about the domain and range and identify the location of any discontinuities. So we're going to talk about what this word means once we see the graph, because I think that will kind of make you understand what discontinuities are. Okay, so number 3, once again, these are piecewise functions, so they have two different pieces. My first piece is the absolute value of x plus 3 minus 1. So if you have your parent chart with you, you know that this parent function is the absolute value, which is the shape of a V. Okay. Number 2, you have 2x minus 5 as your function, which this is just a linear, which looks like a line. So to be able to visualize how these graphs look will give you some kind of hint on how this piecewise function is going to look. Okay? So to start us out, what I like to do is I like to identify the number in the domain that's going to be kind of like a stopping point. So look at my domains in these functions. Remember, they are going to pick right back up. So this one's at 0. So when x is 0, that's going to be right there on the y-axis. So look, I'm just going to highlight it so I know that towards the left should be function number 1. Towards the right should be function number 2. Okay, it's going to pick right back up. Now, what might help me when graphing these is to get a table of values. Now, when I get a table of values, I am going to include that number 0 even if there's no line under it. So if I look at number 1, it just says that my domain is x is less than 0. I'm still going to find that function for when it's 0. That means that on the graph it's just going to have an open circle at 0. Okay, so still identify it. So this is where I'm going to go into my calculator. Go to your y equals. Now I have to have this weird calculator for my iPad, but go into your y equals and type in your function. So this one's the absolute value of x plus 3 minus 1. If you don't know how to get to the absolute value, it should be in the math feature on your calculator screen. You may have to scroll over to number. Okay, so math, scroll using your right arrow key to number. And we can look at the graph if you want, but I'm more interested in the table. So if you look at the very top where you have y equals graph, home, table, whatever, hit the table feature. And this is going to give you so many order pairs. I don't need all of them. I just need a couple so that way I can plot these points. So let's start. I normally start from the smallest to the largest, but if I look here, I want to, let's include -5, -4, -3, -2, -1, 0. Okay, so -5, 1 is my first point. So I'm going to go here and go to -5 and plot 1. Okay, so -5, 1. Then continue doing this until you reach x is 0. Okay, so I have -5, 1, -4, 0, -3, -1. If you hear my dog barking in the background, it's not my fault. -2, 0, -1, 1. And then 0 should be at 2. Now, because that does not include 0 in my domain, I'm going to have an open circle here. Okay, so that's why we're including it. It's going up into that value of 0, not including 0. Okay, now I only graphed a few of these functions, but remember, I should have a V-shaped graph. And it doesn't just stop here. This is going to continue going towards the left. And I can see that by looking at my table. You can get smaller values as you scroll where x is getting smaller and smaller. So by not including that line, you're telling me it stops. So make sure you include the arrow because it does keep going. Okay, so we graphed the first part. Now I'm going to change the color and let's graph the second function. Now this one should be a little bit easier because it's linear. So if you need to go back and get a table of values, please feel free to do that. But most of us know how to graph a linear equation by hand. So if you do, perfect. If you don't feel like it's bad to go get values like we did. But I'm going to just graph this using slope-intercept form, which means I start the y-intercept. So my y-intercept is at -5. So I'm going to go to -5, 1, 2, 3, 4, 5, and I'm going to have a closed-in circle because of the symbol, okay? If my slope is 2, that means I'm going to go up 2 to the right 2, up 2, I'm not sorry, to the right 1, up 2 to the right 1, up 2 to the right 1, and just keep going. Okay, now I'm not going to go down 2 to the left 1 because remember, this is, that highlighted part is where it's starting. Okay, so I only want basically half of this function. All right, so here's my graph. Let's talk about the domain of this graph. My domain of this graph, I can see towards the left there is an arrow. So that means it goes from -infinity. Now, at 0 that's highlighted is a discontinuity. But think to yourself, is there still a value at 0? Yeah, the value at 0 is down here at this point. So this is the value when x equals 0. So you still have a point for there, even though that it kind of jumps. So it's still defined for x is 0. Okay, and then look to the right, I still have that arrow, which means +infinity. So every single value of my domain is represented in this graph. Okay, I know that's a little confusing, so I'm going to say it one more time. Every single value for x is defined by some closed point in this graph. All right? So you can say -infinity to +infinity, or if you see this symbol, just remember that means all real numbers. Okay, range, we typically look bottom to top. So look at the bottom of the graph and let's find out that value. That value should be -5. There should be nothing less than y equals -5 for this function. So I'm going to have a bracket, -5. And I want to make sure that everything else for y is defined. Okay, so I do have a value for -4, -3, -2, all the way up into my arrow. So that will be to +infinity. Now, discontinuity is where there's some kind of jump or hole in the graph, if you would say. If you remember when we were talking about continuity, I mentioned that you could trace the function without picking up your pencil. Okay, so discontinuity, that means that I cannot trace piecewise functions without picking up my pencil, but I want to define where I have to pick up my pencil. So discontinuity, I'm going to define the x value where you have to pick up your pencil. When tracing the graph. Okay, so this discontinuity should be where I highlighted, which is x equals 0. Okay, and this is called a jump. Most piecewise functions have a jump in the graph because it's still defined for x is 0, but it jumps from part 1 up here to part 2. Okay? So I'm going to skip to number 5. The reason why I'm skipping to number 5 is because this one is kind of a tricky function. So if I look, I still got 2 parts. Here's my first one. Here's my second one. My first function, if you look at your function sheet, this should be considered a rational function. So I think we have that, or reciprocal function in our notes. So reciprocal. And just take a look at that graph on your parent function sheet. It looks really weird, okay? So that's going to really affect how we draw this graph. So we have to be careful with that first one. Number 2, that's just the linear, so that one should be fairly simple. All right, so let's start us out by identifying the discontinuity, and I can just look at the domain values, and they should be the same. It doesn't have to be the same, but most of the time there's some kind of jump, okay? So when I go to x equals 1, I'm just going to highlight that area. Okay, and you can go ahead and write it up here if you like. X equals 1 is going to be called a jump. It's going to jump from the first function to the second function. All right, now like I said, the first function here, the reciprocal, is going to look confusing. All right, so let's go to our graph. I'm going to go to the y equals. I'm going to clear this out. And let's type in what we have. That's 4 divided by, put parentheses when you have more than one term in your denominator. Okay. I'm going to just look at the graph real quick. Okay, look at this graph. This is what we're going to draw. The difference here is I'm not going to draw all of this. I'm going to draw it until I see x is 1. So look at the value of -3 for x. If you see, my graph probably gives me this like little dotted line. Yours may not. Okay, so it just kind of depends on your calculator. But -3 is not defined for this function. It's not defined. So go back. We can think about why -3 is not defined. Well, -3 from my domain will give me a denominator of 0, right? So when I go to -3, I'm just going to go back here and make another highlighted area. And like I said, I'm doing that because it's not defined for -3. It's going to be defined for every other number but -3. Okay, so I'm going to have x equals -3 here also. For reciprocal functions, this is not called a jump because it's not jumping at the value of -3. It can't be -3. This has a special name, and it's called an asymptote. Okay, it's called an asymptote. So right now, let's go get some values for this first function. So I'm going to do the same thing that we did last time. I'm going to go to my table. Ooh, it's going to start out with some weird. I'm just going to scroll down a little bit so I get to some decent values I could use. Okay. And try not to use decimals if you can help it. Sometimes you can't. Sometimes you can try to get past it. Use what you can, all right? So let's start at -7. I can plot -7, -1. So that's right here. Let's try to find another. I see -5, -2, -4, -4. All right, so here's what's going to happen. And we saw this graph, right? With asymptotes, this function is going to continue getting closer and closer to x equals 3, but it's not going to actually cross it. Okay, so this function is going to look kind of like this for that first part. All right. So let's go back to our table. Let's get some values after -3. If you look at -3, you should have an error message. Mine says NaN for some reason. Not sure why. But let's do some more values. I see -2, 4, -1, 2. Okay. Let's get maybe one more. Remember, we have to include the value of 1. So let's see what 1 is. 1 is 1. Okay. So when I go to 1, 1, because of my symbol, I'm going to have a filled in circle, okay? If it was just a less than, then I won't. So with reciprocal functions, or rational is another word for them, even though the left-hand side of the graph continues going down, the right-hand side is going to start upward and hit those points, and it's going to stop at 1 for this. If I was going to draw only this function, it would keep going towards the right. All right, but I'm not doing that. I'm stopping at 1 because this is my piecewise. Okay, so now you can take a breath. The hard part's over, thank gosh. Now I want the second function, which is 2x minus 7. Now if you want to graph it, we can. I really want a table of values. I don't know why it starts so high. We're going to start at 1, okay? So go to where x is 1, and then plot negative 5. I'm going to change the color. Now here, remember, look at the symbol. Because it's just greater than, then I'm just going to have an open circle. And then from there, my slope is 2, so I can go up 2 to the right 1. Okay. Now, this is a linear, so everything toward the right of the graph should continue. Now, my domain. I have to ask myself, is there any values x cannot be? We said in the first function that x cannot be negative 3. So I cannot include negative 3 on my graph. If I look at 1, there is still a y value for when x is 1. So the function is defined when x is 1. Okay, you can see that's a closed point. So my only value I cannot have for my domain is x equals negative 3. So there's two ways of writing this. I can say all real numbers, and then add an x cannot equal negative 3. That's one way. Or another way, which is an interval notation, I can say negative infinity to negative 3 union negative 3 to infinity. Okay? Now range, I look bottom to top. At the bottom there's an arrow, so that means it's going to continue going down. That's good. At the top there's an arrow that's going to continue going down. And in the middle, I still have the second part of the function that has all the values in the middle. So this range is going to be from negative infinity to positive infinity, or you can say all real numbers. So that includes this particular problem. Please try the rest of them. I will post the pictures of these graphs, but to make piecewise a little bit easier, just try to get some values using a table feature in your calculator. That will make it the most simple. Just keep in mind to still go to where your domain stops and have an open circle if need be. Okay? Please email me if you have any questions.